All right, example 2 for lesson 3.6, solving trigonometric equations. So here I've got a long equation, and there are a lot of x's and a lot of trig functions, and that's really hard to solve for. So we want to get it, we want to condense it down to something we can get x by itself, where we can get x by itself. And here they want us to find all the x values that work in this equation that are between 0 and 2 pi. Including 0, but not including 2 pi. The brackets tells me that if I get 0 as an answer, it'll be included. If I get 2 pi as an answer, it won't be included because of the parentheses. And then anything between them is included. So when I look at this, I see we've got some matching terms. We've got 2 x's and we've got x's, and they repeat. And that kind of clues me in that it's a composite property. If you look at your list of properties, we've got, this really matches up with that sine of A plus B property, where you've got sine, cosine, plus cosine, sine. So we can condense this long equation into something short, just sine of A plus B. So we can rewrite this as sine of 2x plus x, which is really nice because now we've gotten rid of a bunch of cosines and a bunch of x's, and we've condensed it down to something really small that we can actually isolate x in. Here, 2x plus x actually can go together. That would make 3x. Then we want to try to isolate x. So we're going to get rid of the sine. We're going to do inverse sine to the other side. And then as soon as you do inverse, now you want to look up when is sine 1. You can look at your unit circle or you can look at your chart. And sine is 1 at pi over 2. Sine is 1 at pi over 2, and that's the only place where it's 1. So right now we've got 3x equals sine of 1 is pi over 2 plus 2 pi n. That's your general solution. Then we want to divide by 3 because we're trying to isolate the x. Pi over 2 divided by 3 would become pi over 6. And then 2 divided by 3 is going to be 2/3, or we could say 2 pi over 3 n. That's my general solution. That's not what they asked for. They want all the answers between 0 and 2 pi. So let's start with pi over 6. If I were to, or pi over 6 is between 0 and 2 pi, so that's one of my answers. What if I subtract 2 pi over 3? Well, first of all, I need to think of 2 pi over 3 in terms of a denominator of 6. So I need to get a common denominator here. If I multiply by 2, that would be 4 pi over 6. So if I were to subtract 4 pi over 6, I'm going to get a negative, and I need stuff that's greater than 0. So I'm not going to subtract. What if I add 4 pi over 6? That would give me 5 pi over 6, which is between 0 and 2 pi. If I add 4 pi over 6 again, I get 9 pi over 6. And that is between 0 and 2 pi. If I add 4 pi over 6 again, I get 13 pi over 6, and now that's too big because I can only go up to 12 pi over 6, which would reduce down to 2 pi. So those are my only answers, and those are the solutions.